There's some problem with my keyboard. 1 second. That is our lab, and this is our. 1 second. I'm sharing the screen again. Is the screen visible now?
No, we are not seeing the sharing.
Now it should be visible.
It's loading, should be up now. Yeah, now we can see.
Right. Okay then. So this is the Azure portal, and we are in the lab. 1 second. Where is the lab? For some reason, my keyboard keys are not functioning properly. This one, we need this, and we need this one. Just bear with me. I have some issues with the keyboard. It's not switching properly. Okay, so we're good now. We are here. We created the virtual networks. We created the subnets, and we completed task 1 and task 2. And this task, we are going to create two things: application security group as well as a network security group. So, what is the purpose of this now? What are we doing? NSG will have an inbound security rule that allows traffic from the ASG, and then NSG will also have an outbound rule that denies access to internet. So by default, when you have your virtual network built and the virtual machines, Azure gives you access to the internet automatically. So you don't have to do anything. The moment you have your virtual machines, virtual network built, and the virtual machine built on top of that, you will have access to the internet. So you can control access to internet as well with the help of network security rules. So let's do this one. This task first. Create the application security group. So in the Azure portal, we are going to look for this object, this resource. Okay. So we got application security. We are in the Blade application security group, and here we are going to create the new group. I'll explain you on the whiteboard what exactly we did even after this. So don't worry, just follow the steps, understand the process, how we are creating the security groups. This is particularly about application security group. So in the subscription, we are going to use our subscription, and in the group resource group, I'm going to use the resource group which we used for our virtual networks. And in the name, I'm putting ASD Web, Application Security Group Web. So by this naming is important. As I told you, every resource which you name on Azure when you're creating, whether be it a virtual network or virtual machine or storage, you should follow certain naming convention, and it should be consistent so that you know which resource is what. So like this application security group, we are creating the group. Now you might be if having multiple application security groups required and created later in your infrastructure. So what this group means by the name itself, you should be able to understand. This means this is an application security group, and it is created for uh, grouping the web servers. So when I say ASG-web, by the name, I see that, okay, all the web servers should be part of this application security group. Then it will be easier for me to create the network security rule based on this name. So is US and review and create. That's it. So this is a simple process of creating an application security group. You have to mention your subscription, the source group, and then name and the region. These are the mandatory fields which you have to fill. Okay, validation passed, and here we create the application security group. Now again, this doesn't have any cost implication. On Azure, you should also understand which resource will cost you and how to manage the cost for your organization. So when you create the virtual network, as I explained yesterday, the virtual network itself doesn't have a cost associated. Even the subnets which you create under the virtual network doesn't have any cost whatsoever. You will be charged only when you start transferring data from your virtual network to the on-prem servers or to the other virtual network or to the internet. So there's a cost implication when you start transferring data in any direction. Okay, so the application security group is created now. At this point, you would associate the ASG with virtual machines. These machines will be affected by the inbound energy rule you create in this task, in the next task. Okay, we don't really have any virtual machines here already created. Let's see if we have any previous exercise which explains creating the virtual machines. Okay, we are at this, right? We don't have, okay, so maybe these labs, whatever you're doing in this one, if you do it in the sequence, you see this lab number 8, here we are going to create some virtual machines. So most probably, whatever you're building here, you will be using when you have actual virtual machines deployed in your lab. So right now we're just preparing the network and network related components. Okay, so let's go down. Okay, application security group is created. Now create the network security group and associate it with the virtual network. Okay, so this is what we are going to do now. We are going to create network security group. Again, the same similar way. You can you can easily search for any resource which you want to create in the search bar, and it will directly open that management plane. And here we are going to create the network security group. Again, the mandatory fields, as you see, for each and every resource which you are creating on your Azure platform infrastructure, you have to associate that resource with the subscription and the resource group. So those are the mandatory fields which you require for creating every resource on Azure. So subscription and the resource group is there. Now I'm telling you the naming convention is very important. So this network security group is having the name My Energy Secure. So it's related to security. Is You're going to create this by energy itself. You know that this is the network security group, and you're using for securing your network communication. You might come up with any naming convention. You don't really have to follow what the lab says. As long as you understand what names you're using for which resource, and if you document that, that will be your naming convention. So let's create this. I think, yeah, that's it. We just create validation passed, and you can simply create the network security group as well. So we have created two groups so far: application security group, network security group. Now these groups we just created. We have not linked those groups to any network or any servers yet. So here the next step is basically after the energy is deployed, go to resources. So the energy is deployed, it's created. Once it is created, it is still in progress. You have to go to that energy particularly, go to the resources and go to settings, still in progress. Network security, I think it's created now. So let's go to resources. In the network security group, we are going to settings. We have the settings here, and here we have subnets, right? So it shows you your virtual network, which you created before, and it shows you the subnet. So we are going to link this network security group to this network and this subnet particularly. I'll put all of this on the whiteboard so you understand what we are doing. And here we have an option to associate. Click. So what you're doing is settings, subnets, and then click associate. So you're associating this network security group. You can see this is a virtual network. Which subnet you want? We are targeting shared services subnet. Yes, and we are going to click OK. So that's that will link your network security group to this particular subnet. Now, what does it mean? I will come back to the whiteboard so you'll know what exactly we have done. Right. I think you can see the whiteboard now. Start with the blank. Yeah. So we created network security group. Before that, we created application security group, ASG, and then we created NSG. And at the third step, we actually associated, or you can say simply linked NSG to the network to the subnet. So we have our virtual network. This is the VNet. Within this virtual network, we have created a subnet, core services subnet. Okay. So this is the virtual network. This is a subnet here. And what you have done is you have just created ASG. ASG is not linked to anything as of now. NSG you created and you link that NSG to this subnet. So NSG is now assigned. Consider this as NSG. That means it is applied or linked to your subnet to the gateway. Basically, you can call it you're linking it to the gateway. So what does it mean? So now with the help of this NSG group, what we have created, we can control what communication can go out from your network, what you want to allow. Let's say you have a server here, virtual machine. What connections you want this server to establish, and what can come in to the server, what connections can come into the server. So this is exactly the function of the firewall, a very basic firewall which can control communication. What communication can go out from your subnet and what can come into your subnet. So this is a very simple and basic example. So in networking terminology, you can also call it as ACL, access control list. Here we are calling NSG rules. So with the help of NSG rules, even in firewall terminology, you can call it access control list. ACL or access rules, you can call it access rules as well. So you can say this is an access rule. Okay. These are two different names, naming conventions, depending on what you're dealing with. If you are dealing with a firewall, if this is a firewall, if you have deployed a firewall here for your virtual network, for your subnet for controlling the traffic, it will be called as access rule, which you can implement on that firewall for controlling the communication. If it is plain network switch, if it is a network switch, not not on Azure, I'm just talking generally, network switch or router. It is called as something called access control list, wherein you can define what connections can come in and go out from your network. And here in NSG, in this concept, we are calling it as NSG rules. So we created a group, we linked that group. This is just a group. We have not defined any rules yet for the communication, right? And as you see, as you've seen in the slides, by default, I told you that the internet connection is allowed by default from your virtual network to the internet through Azure cloud. Okay, internet access is available. So that means every virtual machine which you create in your network will have internet access by default. So that's allowed, and we can control that access as well. So let's go back. I hope it is clear what I've explained here, what we have done in the lab. So this is what exactly we have done when it comes to the network security group. Now the next step, I think, it explains you how to create the rules. Let's see. Right. So now we are doing the actual communication control, the rule with the help of rules. Configure an inbound security rule to allow ASG traffic. So what does this mean now? This is also important to understand inbound and outbound, the direction of the traffic. So configure an inbound security rule to allow ASG traffic. That means what we are doing is, I'll explain that in the whiteboard again. Let's continue with this. Continue working with your NSG in the settings, inbound security rules. So we were at, this is our network security group which we created, right? Okay. So settings, inbound security rule. So we are going to inbound security rules. So you can see the moment you created the NSG group, this is a new group which you have created, right? You can see that there are some rules which are by default created for inbound and outbound both, right? You see here, these are default rules. We can't really delete these rules. You can create and modify the rules, anything on top of this. So what are those rules? Let's look at the rules quickly. What does it say actually? It says, and you see the rule names. These are the names which are given to the rules. These are three different rules. These are NSG rules, inbound security rules. So what is the rule? You're saying that, okay, this is the priority of the rule. That means I'll tell you how the priority works. This is also important when your rules are when you have many security rules implemented. So with this rule says allow VNet inbound, right? So by the name itself, the rule by the name of rule, you should understand that okay, this is allowing the connection, inbound connection to the VNet virtual network. And from where it is allowing, this is just a name. It's not actually defining what and who can access it. Port, any port. So you're not restricting anything here. Any port can be accessed, any protocol, and source. Source is the virtual network, and destination is the virtual network, right? And the action is allowed. That means within your virtual network, all the communication is allowed. That's what this means. So even if you have multiple subnets, as I explained yesterday, in one virtual network we created, we have seen on the whiteboard, we create one production subnet and the development subnet, and if I want to control the communication, by default it is allowed. So a virtual machine or a user who is working in development network subnet, that user can access any server in the production subnet. So by that's happening because of this rule. So this rule, this is a default rule, which allows communication across virtual net within your virtual network from one subnet to the other subnet. Then you have one more rule which says allow Azure load balancer. Azure load balancer. 1 second. Sorry guys, that was my daughter. Okay. So yes, so this explains you that load balancer inbound traffic is allowed, and the source is load balancer. We have not seen a load balancer yet, but when you discuss that, you will understand what this rule means. So source is load balancer and destination is any, and the action is allow again. And there is a last rule which says deny all inbound. Deny all inbound any. But that means apart from any of these rules, all the connections are denied. So we'll see when exactly this is applicable and how it works. This is you see in the energy you have two set of rules, inbound rules and outbound rules. That means connections coming into your virtual network and the subnet and connections going out from your virtual network and the subnet. So you have the same rules here, exactly the same rules. Not exactly. You can see that allow VNet outbound. This is allowed. This is the rule in outbound and this is the rule in the inbound, which is making sure that the communication between your subnets is allowed, inbound and outbound. So you need the rules on both the sides. Allow internet outbound. So this is the rule which is allowing you to access internet from your virtual network by default. So there's no control. It's saying that okay, allow internet outbound. So from any port, any protocol, any source, and here it uses the name internet. Okay, and it allows. So Microsoft has the Microsoft controls this what exactly this internet is. So in behind the scenes, that is basically a network which is allowed for every virtual network, right? So let's go to the rules again, which we are creating. So what we are doing is we are creating a inbound security rules. So we have seen default rules. Now we go ahead and click add rule. So these are the options you have when you're adding a rule. And in our example in the lab, on the inbound, add inbound security rule blade, use the following information. Okay. So we are going to use this information now. Source, what is the source we are going to use? Source is going to be application security group. So we are going to use our application security group, which we created earlier. And the name of the application security group, which we created, you see that name is visible here. So just imagine that this group is actually having three virtual machines which are running a web service. So those are your web servers which are grouped in this virtual group in the application security group. Now source port range any port you're allowing the communication. Destination is any again, and service custom notice your choice. So here services in the service, what service we are going to allow? We are going to allow port 80 and 443. So when you talk about web server, you should know that web servers, these are the defined well-known ports assigned for the web server. So your web server will work either on port 80 or 443. Port 80 is nothing but HTTP protocol and 443 is HTTPS protocol. And nowadays on the internet, you will not find many websites which runs only on port 80. It's really rare now because when it comes to port 80, HTTP protocol is not secure. That means whatever you're transferring or accessing through HTTP protocol, that traffic can be seen by anyone who intercepts the traffic, who intercepts the packets. So it's always a best practice to go with 443 HTTPS traffic, encrypted traffic for your websites. You should always use HTTPS protocol. So 80 and 443, then protocol is TCP. Okay, and the connection is allow. We are allowing the connection and we are setting the priority 100. Okay, that's the that's the rule set which you're creating. Now, what are you doing with this rule? You're allowing NSG, ASG. Allow ASG. You can also say that web servers, right? This is one rule we have created. So did we create in a wrong direction? It should have been in the inbound one, right? Inbound security rule. And I created this in outbound. Now what can I do with this? I have to delete it. Let's go through this again. Application security group, LG web. Now, if you know the TCP/IP fundamentals, you definitely should know what each of these parameters means. What is the port number? What is the protocol? And how they work on internet? Because this is not the session where I can explain you each and everything. But I'll definitely guide you, suggest you to go through some material which if you have not, if you don't know that these things, these parameters, then it will be really tough for you to manage network security rules of the groups and manage the firewalls on the Azure cloud or anywhere in your on-prem setup as well. So the concept remains the same. What you need to know is the difference between port 80 and 443 and protocol and so on. So those are all networking fundamentals. So I will definitely guide you if you don't know, if you don't really have any basics or fundamentals on networking. I'll suggest you some videos. We can go through that, and probably that will give you some nice explanation on what each of those means. Protocol, are we going to do any? Yes, the destination is any, and custom port, destination port number. We are allowing 80 and 443. Protocol is TCP. The action is allow, and the priority is 100. And this is the group name. We are giving the name, adding the name web service for our understanding. Okay. So now we have the rule in the right place. So what have we done? We had the default rules. We created one rule on top of that. And what does that rule say? The priority of the rule priority is 100. That means the lesser the number, the higher the priority. That means when the traffic comes in, it will process this rule first before processing these rules. So the moment traffic comes on your network, it will check, okay, this server, whether this server is part of the group, allow ASG. ASG, this is the rule name. This is nothing but a rule name. What are we doing? We are allowing port 480 and 443. Protocol is TCP. This is where you are defining your ASG actual group. The source is our web servers, destination is any, and we are allowing the connection. Okay, that means we are allowing access on port 80 and 443 to any destination for this web servers. I'll explain you that on the board again. Let's create one more rule. Create an outbound energy rule that denies internet access. Okay, so after creating your inbound energy rule, we are creating the outbound energy, security rule now. Notice, so let's go to the outbound security rule, and we have seen that there is a rule by default which allows internet access to any virtual machines, right? So now what we are going to do, we are not going to allow access to internet for everyone. Notice the allowed internet outbound rule. Also notice the rule cannot be deleted, and the priority is 65001. So you can see that you can't really select these rules. As I told you, these are the default rules. You can't delete those rules. You can create and modify the rules on top of these existing default rules. So let's click on add, And here, let's follow this process again. Source any. We're saying any source, uh, s- any port number. Star property means any port number. Destination is service tag. We're going to use destination service tag. Okay, service tag. In the service tag, we are going to use internet. So in the service tag, we have multiple options. We are going to select internet. So we are saying that anything to the internet. What is the action? Custom. The service is custom. Okay, and destination port range is star. That means star means any. Protocol is any. Protocol is any. Yes, and the action is deny. Action is deny, and the priority of the rule is 4096. This priority really matters when you have multiple rule sets. We'll see when we use that, what priority we set for which rule. The name of the rule is deny internet outbound, right? The default rule says allow internet outbound, but we are overriding that rule, saying that we don't want all the servers to have internet access in our virtual network. So I'm going to create that rule now. So, okay, so we have our outbound rule created now. So what does it look like? You see that we have the rule priority of the rule number. The name of the rule is this: deny internet outbound. any any that means we are denying internet access for anyone on our virtual network. So direction is destination is internet and the action is deny. So now we can understand the rule preference. So if someone is trying to access the internet, this is the highest priority, right? The lowest the number, the highest the priority. Your traffic will first hit this rule, and here itself you are saying that deny access. So even though you have a rule with the highest number, lowest priority, saying that allow internet access, your traffic will not even come to this rule. It will be dropped here itself, right? So this is how the rule priority works. So I'm going back to the whiteboard to explain you this so that it makes more sense to you guys what we have done. Okay, so we are back on the whiteboard. Let me explain you what we did. Make it clear. Okay. So we have our virtual network, VNet. We have our subnet. Okay. We don't have any virtual machines yet. We're just preparing our network for our deployments. But for your understanding, let me just draw it. So let's say these are two virtual machines I have. This is my web server, web one and web two. Okay, so what I've done is, so by default, this is a gateway. Azure subnet. It's not visible anywhere. You know that when you are creating a subnet, you are having a default gateway created, right? So that's your entry and exit point to uh, the subnet. So from here, communication goes to other virtual machines or the subnets, or it can even go to internet, right? So what we did is, by default, this internet access is allowed. allow all outbound internet, right? That's the default rule we have. So every virtual machine is now remember, I told you NSGs can be applied on two different levels. Can anyone tell me which levels we can apply the NSG rule on? Yes, anyone?
Yeah, Maksud bhai, sorry. What was your question?
The question is NSG network security group can be applied on two levels. What are the
On the
two
NIC
levels?
level, subnet and the NIC.
Subnet level and the NIC level. NIC is nothing but the virtual machine which you're talking about.
Yes.
So every virtual machine will have a NIC. So basically the NSG can be assigned to a subnet or NIC, which is nothing but a network interface card on the virtual machine. So you can control the communication on these two levels. So here in our example, we have created the network security group and we have assigned it to the subnet on the subnet level. So on the subnet level, we are controlling the traffic. So what are the rules we have created? Firstly, what we did is we created application security group, right, with the name ASD. This is what we did. Okay, so logically it will have all the servers within that group. And secondly, we created a network security group and we assigned that group to this subnet. And on the fourth step, what we have done is we created the rules, NSG rules. Okay, what rules we have created? We have created a rule for inbound connection and outbound connection. Okay, so in inbound rule, what we did, we are allowing from any source. Can we just quickly see what we have done? Look at the lab guide which if you have in front of you. I'm taking as well. Okay, so in inbound rule, what we have done is we have mentioned source as the application security group, ASG group, which is nothing but these web servers. This is the first thing in the source what we did, and we are targeting the application security group particularly in destination and the port number, source port. That's also important. Port is star. That means any port from any from ASG. Destination is any again, any destination. And what is the port we are allowing? Protocol. We are allowing the protocol TCP. That's because port 80 and 443 are the protocol are the ports which runs on TCP. Protocol TCP and then action is allowed. Right? So what is this rule doing? This rule is for the inbound connections. That means this NSG, the network security group which we have, is allowing the communication from ASD to the now it doesn't now this subnet this rule is wrong actually because in this example this subnet these virtual machines are not in this subnet. That's why we are creating inbound rule. So let's create one more subnet. I'll explain it. That will make it more clear for you guys. Let's say we have one more group, one more subnet. Okay, and I have this network security group is applied on this group, this one. So let's say I have some servers here, virtual machine. I have a user here, a developer user who is working. Let's say this is a user machine, virtual machine again. So let's say this is a dev subnet, and this is our production subnet. Okay. So now this rule makes sense because what we are doing is uh, source. So this is a little confusing for me as well. Source is AG and the protocol and the ports are TCP and 8443.
We have to
Okay,
form a web group, I think, for all
web
the
group
web
is
servers.
yeah, web group is there already. We have created. Okay, let me come back to this later. We have more examples coming up. Let's not confuse ourselves and waste time. Let's look at the other outbound rule, which is much more clear and easy. I'll explain you. So we created an outbound rule. I'll definitely touch base on that one where we can use that rule. So in the outbound rule, what I'm doing is basically I'm saying that by default the internet is allowed. I don't want any of my servers in this subnet to have access to the internet because usually you don't browse the internet from the server, right? From the server. If you have a server in infrastructure, let's say on-prem, you're having an on-prem setup, you have servers. You do not log into the server to browse internet. Hence, it is not required for a server to have direct internet access, and it's not a good practice because if your server is having direct internet access and people are using that server to browse internet, then you're exposing your server for malware attacks and virus infections. So what we do in the enterprises in the organizations, we do not allow the internet access for servers. So I'm creating a rule in the outbound connection saying that any any source is any and destination. What is the destination? We're using the service tag. You remember we have not defined any IP range because we don't know on internet what IPs are there. There are millions of IP addresses, right? So Microsoft has created a service tag called internet. So you just use that service tag and Microsoft will take care of everything in the background. So it refers to any internet as a service tag, and the connection we are doing is deny. The action what you are doing is basically deny. So this the outbound rule really makes sense. The inbound rule, I just need to understand that why we are doing that rule. But just understand that for the outbound, we are creating this rule to control the access to internet for our servers. So going
Also,
back
by
to
one
the
question.
yes,
Yeah.
yes,
In your example, we have
mm,
associated production to NSG. So if you are
right,
going to apply for the other subnet, we need to associate that with NSG as well, I
exactly,
guess.
exactly, exactly.
Yeah.
So you for every subnet, if you want to control the traffic flow on that subnet, in incoming connection, outgoing connections, you have to have the NSG applied on the subnet level, and it is a best practice. Though you can assign this NSG to a virtual machine directly, the NIC, but there's a recommendation that you do it on the subnet level. That really makes more sense, and it will be easier for you to manage instead of doing on each and every virtual machine level. But you should understand, you should know that you can also do the NSG rules on the virtual machine level too, right? Now here we come to the public configure public and private DNS zones. Now for that, we'll go back to the slides again. We'll just run through the slides and then we'll come back to the whiteboard. Okay, so we were at DNS, right? Right. So let's go through the DNS. What is Azure DNS? When you create a new tenant, a new default domain is created. Okay. The domain name has initial domain name in the form domain name dot on microsoft.com. This is how it creates a domain name for you. You can add a custom domain name. After the custom name is added, it must be verified to validate ownership. Yesterday, we have seen that the domain names can be bought, purchased online. So if you are launching your own website, you will definitely like to have your own domain name, which will be used by the internet users to access the services or the products, whatever you're focusing on your website, right? So in here, when you create a tenant, when your Azure subscription is created, there's a tenant created with it, the AD enter ID tenant. Along with that, there's a DNS also created, domain name is also created with it. So it creates a custom name. This is how it creates it. You don't use it anywhere as of now. Domain name, you can name anything, you can give any name. Usually it will be your organization name dot on Microsoft.com, but you can't use this for hosting your websites. So this is just internally used by Azure DNS. You can add a custom domain name. We'll see that what is the scenario where we use that, and create a directory. Here we can see that in your Active Directory, this is the screenshot from your Active Directory. So the enter ID is created, and along with the enter ID, it creates a domain name for you. So this is how it creates it. For example, Azure readadmin.org on Microsoft.com. We'll see where it is used. Now, if you have your custom domain name, as I explained you, if you want to have your own domain name, you want to have your own website running with this domain name, then it will be uh, something .org, .com, .net, whatever domain name you want. You can configure that domain name on your Azure DNS. Configure Azure DNS to host your domain. You can do that. A zone has a DNS zone hosts the DNS records for a domain. Where multiple zones share the same name. Each instance is assigned different names. Now, let me do one thing. I'll quickly explain you how DNS really works. Then we'll come back to this slides. Okay, in the previous example, I can, just give you one scenario where we can use the inbound rules. Let's say this is our virtual network. Okay, we have, I'm not following the lab example here. I'm just giving you the use case where you can use, let's say this is my subnet, where you can use the ASG application security group, and we have our web servers, web 1 and web 2. We created a application security group. So this is my ASG, I name it web servers. Then I create the NSG, and then I associate the NSG with the subnet. So this is, let's say this is subnet 1, which is my production subnet. Then 4, I create the rules. So now what rules I need? Let's say I'm hosting a real web server on this virtual machines. So I have a website, for example. My website is www.abc.com. Okay, so you know the process. You have to buy the domain name, and then you have to either host this website on any hosting provider. There are many hosting providers. What exactly the hosting providers do? They provide you the space, storage space, and they also provide you the public IP address. All of this is provided by the hosting providers. There are many hosting providers. GoDaddy is one of them. There's Hostinger. and many more. So, what you can do is we simply, if you are hosting with this hosting providers, you have to choose this option. If you want to host yourself, now in our scenario, we want to host our own website. So I don't want the third party to host my website. So I want to host my own website. So what do you need? So you purchase the domain, then you have to configure your DNS. So this will be now on Azure. So your Azure DNS has to be configured. So how do you configure it? You need a public IP address as well, right? So you will say that, okay, any request coming to for this domain name, it will be mapped to my public IP. For example, I have public IP address 5.2.3.1. This is my public IP address. This is what I do on the DNS level. I'm mapping the names to the IP addresses. And thirdly, what I can do is, okay, this is it for hosting. So I got this web server here, two web servers running my website www.abc.com. So I configured Azure DNS. Azure DNS is associated here with the VNet. This is my Azure DNS. So I configured this domain name, and I have my public IP also assigned here. So this VNet is also having. So now this IP is assigned to me by Azure. So I'm using this IP. So in this scenario, now I want to create the rule. What rules? What is the rule I need? I want everyone over the internet to be able to access my web server. So let's say I'm the user here who is connecting to internet. Okay. So I type in www.abc.com as a domain name, the website, and I get the IP address from the DNS server, wherever the DNS servers are. So I get the machine gets the IP address that your website is hosted on this particular IP. So the request reaches my Azure network. So over the internet, the request comes here. Now, when the request comes here, what you have to do, and how do you access this site? It will be, if you are doing it with HTTP, it will be port 80, right? The request will be translated. Your request in the background, it goes on. Basically, it lands on this IP address and on the port number 80. Port number 80 is HTTP. Okay. And HTTPS functions on port 443. So if your website is secure, you have the certificate installed on your website, HTTPS www.abc.com. It will use a secure communication. So your request will come on port 443. This IP, same IP address on port 443. Now you don't define those ports on your browser. As a user, you don't do that. You either type HTTP. Nowadays, port 80 is not used because of its security, because of the privacy issues. This connection, when it happens on port 80, anyone on the internet who can intercept that connection can see the traffic flow. They can see the real content of that packet, what is transferring between you and the web server. So nobody is going with the port 80, and it is being phased out. Unless you have a very specific use case, you can use it internally. Otherwise, it's always recommended to go with port 443. That means the connection will be encrypted between the user and the server. This whole connection will be encrypted. Nobody can tap into this connection and see what data is being transferred over the connection. So port 443 is the one which is preferred here. Okay, so this is what is happening. So you, as a user, I type in the domain name, I get the IP address, and I'm accessing this website over the port 443. When it comes to your Azure, it reaches your Azure network. This IP address, you'll be actually mapping it to a particular web server. If you have more than one, then there's a concept of load balancer. We'll see that in the next slides. You can use load balancer instead of assigning this IP to one particular web server, because here in this scenario you have two servers, but still you're making use of only one server, which is available for the internet users. So there's no point having the two servers here. So we'll see the concept of load balancing where we need it and how we can make use of it. So here, in this simple scenario, the request is coming here. Now, I don't want anything apart from except port 443 over the internet. So my rule should look like this. Now I'm coming to the rule now. So this rule should have uh, the connection communication like this. So here I will say in simple terms source. Now what should be the source here? I want you guys your input. Just to
Any,
understand that it has to be any. Why any?
any, anyone from internet, they can, any user, like from any part of the world, they can connect, right?
Any user. The see you're hosting a web server, right? And that means you want to make this web server accessible to everyone over the internet, right? Unless you have there are certain cases, like for example, I'll tell you, uh, there are certain government sites which are not accessible out of the region. That means they implement such rules wherein if the request is coming from US, for example, the Indian website, try to access one of the government websites. Some websites are blocked that you can't access from UAE. So they are controlling access to websites as well. But if those are sensitive websites, but in general, the common practice is if it is a website for your for about your company, if you're selling something on the internet, you want this to be available and accessible to everyone over the internet, right? So the source, you have to leave the source as any. And what is the protocol? Uh, Protocol would be TCP in here. In
443.
this protocol is
HTTP
TCP, and the port is 443,
443.
right? So now, okay, you want to keep this website accessible over the internet, but not for every port, right? You know that your website is working on only HTTPS access. So you will be allowing only 443 access in this scenario. And what will be the destination here? Source is any destination. Here in destination, I can mention my web server. In this example, because I don't have load balancer, I can define web server where the public IP is mapped to. Or if you have load balancer, if you have multiple servers, then we have seen the example of an ASG, right? Application Security Group. So if I have multiple web servers and I have the ASG group, I'll use my ASG group here, ASG web servers. This will be my destination. And again, protocol will be TCP and the port which I am allowing is 443. The source in the source, you were right. Actually, we put TCP, but port any. We don't mention the source in the port number in the source. So source is any, protocol is TCP, but port has to be star. That means any port from the source. Destination site, we have to mention that port is 443. So that means anyone over the internet browsing this website over HTTPS, when the request comes in, my NSG rule says that, okay, it will evaluate this rule. It will say that, okay, the rule says from source any TCP protocol, any port, destination is web servers, application security group, which you define port protocol is TCP and port is 443. So this connection will be allowed and the action has to be definitely allowed in order to make your website accessible over the internet. So this tool makes sense. With the help of ASG, we are combining multiple IPS web servers in order to simplify our rule set. This is the incoming connection, and we have already created an outbound connection wherein we don't want anyone to browse internet over from our web servers. So we are hosting a web server. This server has to be secured. So we just want anyone to access the internet from our website server, but we don't want anyone to access internet from the web server. You understand my point here, right? So This is the security rules, the energy rules which you can create in this scenario. So we were discussing the DNS, right? Let's go to the DNS. Now, does anyone know this? The full form of the DNS? It's a domain naming system, right? There are multiple abbreviations available. Domain naming server, domain naming system. What does it do? What's the primary function of DNS? It's a name. It resolves names to IP addresses, right? That's what DNS does. Name resolution. Now, it is one of the key component of internet. The IP, Internet Protocol, DNS. These are, you can say, these are two pillars of internet. The whole globe, the internet, which is functioning, is functioning on these two major components: DNS and the IP protocol. Right? We know that DNS does the name resolution. It does mapping of names to the IP addresses. Now, DNS has different records. This has something called resource records. Resource records. And this you have a record, which is called as host record. You have, I'm just giving you high level again. A record is used for IPv4 addresses. Then you have pod A record as well. This is used for host record again, but used for IPv6 addresses. We have MX record, which is used for email service. And there are many more. There's a PTR record, which is called pointer record. And there are TXT records, text records. There are many different records you can create on DNS. Let me give you a quick example and this of one of the record. And there is alias record, that is very important. Alias record, uh, which is, I'll tell you how it is used. So let's see this. I have my DNS server in which I'm managing the zone, DNS zone. It is called zone. So in this DNS zone, you will have your domain name defined. For example, abc.com. So when you're managing the DNS, you will see it like this. So the DNS server has a zone. This is also called as forward lookup zone. Forward lookup zone. What does it mean? It means here it does name to IP mapping. Okay, or service to IP mapping. Name to IP mapping or service to IP mapping. This is what DNS does. Okay. Now this is my zone. Just give me a second, guys. I'll be back with you. Sorry guys, I'm back again. Okay, so we are here at DNS description. So now abc.com, if it is just a web server which you are hosting with this domain name, you will have uh, mainly two records: name server record. This is called name server, and you will have a record. If it is IPv4 address which you have for your website, and it will also have CNAME record, canonical name, or you can also call it as alias record, which will be www. These are the entries we will have. So if I have a web server, let's say again going back to the scenario. So this is our network, VNet, subnet, and a web server. And this will have the IP address assigned to it. In this scenario, let's say we have the public IP directly assigned. But although this is not the practice, this is not a real-time practice. We don't assign the public IP address directly to the web server. Okay. So your VNet is connected to the internet. And this is all happening on the internet, right? This DNS server, this this configuration, what you're saying, the zones, the domain names, and the records, it will all be created on the DNS server. So who manages the DNS server? If you're having, if you can do it yourself on Azure, you can again that's the cost. You can buy the DNS domain name and manage your domain name on Azure platform itself, or it can be a third party provider, any DNS the hosting provider where you can buy your domain name and manage it from there, right? So this is what you have to do as a system admin. You can say this is your responsibility to make sure that this information is correct, because this is where exactly you're saying where your web server is hosted. Okay, so a record is the real record, which this is the main record wherein you map your host name to IP address. So host record will be created. For example, I create the host record, and I can create with any name. It doesn't really matter what name I use here. I'll say web server one, for example. Web server. This is my name of the server, and this is the IP address. So I'm creating a mapping here for my web server. This name is not really important here. This IP is important, and I'm also creating a alias record with the name www, and I link this alias with this source record and the DNS. So what will happen? And the name server where it should resolve the domain name. So name server will be defined by it will be automatically defined. If you are hosting this, if you are managing this Azure your domain name on Azure, name server will be from Azure platform. Microsoft has defined name servers. They will you can use it from. Okay, actually it is pre-configured. You can't really change that. So this is how it will look like on the DNS site. So what you're doing here, you're mapping the name to the IP address, and you're also mapping a service to the IP address. So you're mapping the service www. So when a user browses the internet, this website, if it is a user, and when he types abc.com, so this request goes to the DNS, and on the DNS, it will look for this, the first bit of the URL, www. What exactly this means? From the DNS, it sees that, okay, this www record, that means a web service request, a website access request. This is mapped to this particular IP, the public IP address. So it gets the public IP, and it is under this domain name. That's important. So, based on the domain name, it will reach out to this particular DNS server, name server, first of all. So there can be many name servers on the internet, but since your domain is under .com, so this is again a hierarchy. And in the internet, in the real time in the internet, you have a root domain, which is managed by the INA authority. You have .com domain, you have .net domain, right, and so on. And you have country-specific domains as well, like that .ae. So these are something which are managed by your international organization. Okay, so when you buy a specific domain name, if you're buying it under .com, right? So the request when the user browses and request, it goes actually it goes from here. It goes in this direction. Will be the request will be evaluated from this direction, from root domain. That's the root domain which is not visible to us. Under root domain .com, it goes to the .com DNS servers. From the .com DNS server, it goes down to our specific domain DNS name server, where we are hosting abc.com. And then under this domain, so it reaches here, it goes here first to the root, to the .com. The request, this is all happening in the background, and it's happening in the macrosecond time. You know that it's all the moment you type in the URL, you get instantly the web page loaded on your web server, right? It's all happening so quickly. You don't really realize what's going on in the background. But in reality, this is what is happening. Your request is going to the DNS server, is going to root domain .com domain. Now this doesn't happen all the time. Uh, we'll learn about DNS caching as well later. So it goes here root.com and to the specific name server, which is hosting your abc.com. And within that abc.com, now it looks for this. This is the actual bit your browsers were looking for. What exactly this www means? So it comes down to your DNS zone. In the DNS zone, it looks for alias record, and that alias record is maintained. So this is how the user, you as a user, your browser is fetching the IP address, the actual IP address, which it needs to access the web server, which you are hosting. So the moment it gets the IP address, 5.1.2.1.3, then there will be a request directly going from your machine over the internet. Again, directly means it will be over the internet to your web server. This is the process which happens in the background. Name resolution, wherein it does the service to IP mapping. If it is a web service, it will be www. So in the DNS, you're telling what service is this? This is web service, and which server is hosting that web service. So you're mapping the service to the IP address here. Okay. So this is what this DNS, all of these DNS functions you can control yourself if you're managing your own DNS domain names on Azure platform. Right. Let me go back to the slides. I might not have explained it very well. Believe me, there are really nice videos which explains it deep down and very detailed and very in a very good way. So I definitely encourage you to go through some other videos understanding the DNS as well, how DNS functions in the background, because it's a very big subject. Each of this, what we are touching in this series, IP addressing is a huge subject by itself. Um, the OSI layers. I don't know if if you know about OSI layers. That's really a very important topic, and you'll see the importance of it going forward. So here in this series, we are touching all those components on a very high level in order to deploy and manage those components on Azure platform. Understand? So the time doesn't really permit us to go deep down on each and every technology and discuss and understand the mechanics of it and the background process of it. So what is Azure DNS? When you create a new tenant, we know that it's created automatically. It creates a domain name for us, but that domain name we can't really use for hosting our web server because nobody will prefer to access your website abc.onmicrosoft.com, right? You will people always prefer the direct website names. You can add a custom domain name. This is where you will have to do that task what I've shown you. You buy a domain name abc.com and then you configure on your Azure platform. When you configure it, you configure the resource records in it. Name server record will be automatically created. You will have to create the host record and the alias record, bare minimum at least. If it is just a web server which you are hosting on your Azure platform. Okay, so we'll see that configure Azure DNS to host your domain, right? It says I'll just read you through it. Whatever I've explained. A DNS zone hosts the DNS records for a domain. As I told you, there are multiple DNS records you can create: host record, alias record, MX record, and so on. So there's a purpose. There's for each record type is used for a different purpose. We have seen alias record www. It is used for identifying the web server on your DNS from the DNS. When you use MX record, that will be used for identifying the email server in your environment. So which public IP is hosting your email service. So where multiple zones share the same name, each instance is assigned to different name server address. We'll see this all of this when we are doing it in the lab. Root parent domain is registered at the registrar and pointed to Azure DNS site. Oh, sorry. Screen is not visible. The screen is not visible. I'm sharing the screen. Shall I reshare it? Let me show that. Until now, you were not able to share the screen. You were seeing the whiteboard, right?
No.
You didn't see the whiteboard. Oh my God. So what
No,
are
sir,
the
we saw the whiteboard, but after the whiteboard, now PPT is not.
okay, whiteboard DNS explanation, you have seen it, right?
Yes, yes, sir. Yes.
Okay, let me just double check and confirm because otherwise it would have been a complete waste of explaining what I've done. Let me just take your confirmation whether you were able to see this part. 1 second. See, all these topics I'm touching on very high level because I told you these are very detailed topics. This you have seen, right?
Yes, yes, yes.
Right. So after this, actually, it was going to a different screen. So let me show that again. Okay. So I hope you can see that now. The presentation is visible. Right.
Yes, sir.
Okay. So let's carry on with this one. Right. Here it says you do not have to own a domain name to create a DNS zone with that domain name in Azure DNS. So even if you don't own the domain name abc.com, you can still go ahead and create the DNS record, but that won't be of any use. So let's move on. Validate delegation of domain name service. We'll see when this is required. When you go with the third party DNS service, when you're buying a domain name from someone else, and you still continue to keep your DNS configuration with the service provider, then in that case we have some options for delegation of domain name service. We'll see that later in the practicals where it is used. Configure a private zone. Use your own custom domain names. Provides name resolution for VMs within a VNet. Now you can. There are two things in here. There's Azure DNS, which we talked about, which relates to the public domain name ABC, for example, abc.com. And there is a private DNS zone also you can create in Azure. which will be used particularly for internal name resolution of your servers. So provides name resolution for VMs within a VNet between the VNets. Automatic host and record management removes the need for custom DNS solution. Use all common DNS record types. These are the common record types I have explained you. A record, COD A record, CNAME, MX, PTR, SOA, service account, and text records. Uh, I'll give you one more explanation where DNS is really important in the internal communication. I'll give you one explanation on the whiteboard. Okay, available in all Azure zones. Next, here is a simple example. This explanation is for this diagram is explaining the private DNS. So within your virtual networks, you can see here virtual network A, virtual network B. There are two virtual networks, and you have virtual machines created in each of those. Now, you want to enable the name resolution for this VM. That means from this VM, if I need to access this particular virtual machine, I should be able to access with the name VNet B dash VM3 instead of knowing the IP address of that VM. So how can you do that? You can only do that with the help of DNS, right? Because if your machine, if you don't have a DNS server which does that name to IP mapping, you won't be able to reach this server with that name. So this is where you can make use of Azure private DNS. You can configure your own DNS server with a specific, either you manually create these records in your DNS server saying that VM1 has this IP address, VM3 has this IP, VM2 has this IP. Or you can enable something called auto registered. So on the VNet level, you can do auto registered. Once you have your private DNS configured, every virtual machine which you create in that VM in the virtual network, it will register its name in the DNS server. So when you build this virtual machine VM1, for example, in VNet1, and it has this IP address, so this virtual machine will automatically register its name and the IP address. So IP and name and IP mapping will be registered in the DNS server automatically. So you see this records. This is the private zone records in the private DNS server, which are automatically created. So even if you change the name later of the server, this will be updated automatically in the DNS server. So you don't have to really manage the DNS manually yourself, creating the host records for each and every virtual machine in your network in the VNet. So this we are talking about the private DNS here. This is not the public DNS wherein you are managing the host records for your public domain name like abc.com, right? So we'll see how to install, configure the private DNS as well. Then we come to another interesting topic, inter-site connectivity. This will help you in connecting different virtual networks and different regions as well. And also connecting your virtual network to the on-prem network. So that's called inter-site connectivity. So we'll be understanding what is virtual network peering. What is the difference between system-defined routes and user-defined routes? There's a routing also, a little bit of routing which you need to understand on Azure networking. What is the difference between a service endpoint and the private endpoint? These all of this, each of this topic is, very huge in itself. So let's see. Before we continue this, let's look at the DNS part. So what we can do is we can create some views before that. In order to see this, all the NSG rules and everything. So are you comfortable so far, whatever we have discussed? You are okay? You have any questions? Where is that link which I had shared with you guys? Let's see. And that has all the labs are there. Actually. Share. This is let's create some virtual machines. Let's see what this exercise says. How many VMs we are creating? We are discussing more advanced topics here in the virtual machines, deploying resilient Azure virtual machines, manage compute and storage, scale virtual machine sets, create virtual machines using PowerShell. Let's go to the task 5 and create some virtual machines in our network. In this labs, we're discussing all the related options in virtual machine. So we have not reached there yet, but just to show this labs, what do we have next in this? In the networking, we have seen how to create the NSG and AC. Okay, let's do one thing. Let's continue doing the private zones. Actually, the name resolution part, you can see it when we have the virtual machines done. When we deploy the virtual machine. So here we will just discuss and configure the private DNS. Let's do that. Right. So far we have done 3 tasks. I hope it's all clear for you guys. Creating the virtual networks, do the lab yourself. You will understand if you are missing or having any errors while creating the virtual network in the subnets. Through the portal, it's very straightforward. But when it comes to the template, that's where we had the error. But again, I followed the exact steps. There was one issue we found from the template that it was creating a default subnet with a different IP range and it was failing. So even the second time we ran the template, it actually gave an error, but the task was completed, which we didn't check in the live session yesterday. Immediately after the session we ended, I checked that the VNet was created and the subnets were created as well. So the template also works fine. Then we have created application security group and network security group. Though we have not seen in action uh, how exactly it is, controlling the traffic flow. You can do that when we have the virtual machines deployed. And if you go in this sequence, we'll have the VMs deployed in the lab 8. So we are still in lab 4. We have many labs to go. So here we are understanding and building the ground components which are required for deploying the virtual machine. So we're laying the foundation for our virtual network, subnets, NSG rules, application security groups, and so on. And then now we are configuring the private DNS zone. It says configure public and private both. So let's see what it is showing in the lab here. Okay, so you can configure Azure DNS to resolve host names in your public domain. This will be applicable if you have your own domain name. For example, if you purchase the domain contoso.xyz.domain names from a domain name registrar, which I told you some names for the domain name registrar from where you can buy it. Yesterday we have seen GoDaddy is one of them. You can register your domain and buy the domain from that company. Similarly, there are many other domain name registrars available. If the domain name is already occupied, utilized, used by someone, we can't buy that. You have to look for another domain name. So you can configure the Azure DNS to host the contoso.com. So in this example, let's say we have purchased our domain name and we want to maintain, configure and manage our own DNS records for our domain name, contoso.com. So in that case, what you have to do, you buy the domain name and then you configure it to resolve for your website. the specific IP address. Resolve www.compressor.xyz to the IP address of your web server. So this is the process. We'll follow this, and you will understand by doing this in more detail. Let's go back to the portal. Okay. All right. So I'm on my Azure portal now. Right. So let's look for DNS roles. Right. So here we have an option to create. Again, if you see here, every resource which you create on Azure, it has to be linked to the subscription and the resource group. That's really important. We can't really skip that and create any of the any resource on Azure. Configure the basics tab. Let's go to the basics tab. Here in the basics tab, we have selected subscription resource group, and now here it says the name. What name we are going to select? Contoso.com. Okay. If you have your own domain name, you can say here you're getting a error. The DNS zone name you entered is reserved. Choose a different name. That means somebody is already using this domain name. What if I put abc.com? It is checking these names instantly over the internet. abc.com is available. Really? What if I do google.com? It's not checking these names. Why? So you can create any name here, but it will not be working. It doesn't mean that you are hosting the Google servers and the google.com records will come to you. So only for contoso.com we got error. Okay. So let's say I'm creating my website in the example what we did, abc.com, right? And again, you have to select the resource group locate. It's actually grayed out your location because it is taking to the location where your resource group is created. ECUS, right? Review and create. And here we're just creating this domain name. Okay, it is passed. Let's clear it. Wait for the DNS zone. Okay, then go to the resources, right? Okay, go to the resources. This is how your DNS management looks like. So if you are buying a real domain name from the public domain registrar, you can configure your DNS on Azure platform itself, or even if you're hosting it some other service providers, they will give you access to manage your own DNS records as well. So we are on the domain name abc.com. Now in this domain name, what are we going to do? Overview blade. Notice the name of the Azure DNS name service assigned to the zone. Okay, that we have seen. Copy one of the name server address. Where's the name server address? See here. These are the name servers which are managed by Azure Microsoft. These are name servers which are necessary for this is a very important part of the domain names. So this shows you where it is creating the zone records, the DNS zones and the records. So it says copy one of the name server address we need in the future steps. Okay, let's copy this one, name server 1. Now expand the DNS management blade and record sets. Expand the DNS management blade and go to the record sets. This is where you see the records which you create for different services. As I told you, you can create a record, a DNS record for mapping your host name to the IP address and mapping the service to the IP address. So what are we going to do here? Once on the overview blade, notice the names of the 4 Azure DNS name servers assigned to the zone. Okay, that we have seen that. Expand DNS management. We are here. Now we are going to create a add the record. So what is the record? Where is the option to add? You see anywhere? Don't see an option here. Okay, it's here. Add the record. Now what is the record you want to create here? It says name of the record is going to be www, right? And the type of the record is going to be a record. You can see a record, IPv4 address record, right? If you have IPv6, you will be creating cod a record. So this example, in this example, we are going to have IPv4 record and the TTL value, time to leave. I'll explain you later what exactly it means. IP address, and here we are using the private IP here, just for example, for creating this record. In a real world scenario, you would enter the public IP address of your web server. You got the point here. This exercise we are doing just in order to just see how you manage your DNS records on the public DNS server. Okay, so what I have explained in the whiteboard, the public IP which you'll be using for your web server, you'll have to use that IP address here. So we are just creating a record now, simple record. Select add and verify. Your domain has a record in the www record. Okay, so let's go and see. So we have this record created now. So www name of the record, type of the record is a record, and this is a TTL value, time to live. TTL stands for time to live. This actually explains you the refresh time for your DNS records. So whenever you change anything in the DNS records, IP address or anything relating to the DNS records, it will take this much time to refresh your DNS records across all the DNS servers in the internet. So this is in minutes. TTL, I guess it's in minutes. So you can calculate how many minutes it takes to refresh all the DNS servers on the internet. So then next, open a command prompt and run the following command. If you have changed the domain name, make adjustment. Okay, so we are going to open the prompt here itself in the Azure. We are on shell. We're just making sure that name resolution is happening or not. So let's move to the shell. And we are running the command. We have seen that yesterday, nslookup. This is the domain name. We have used the domain name abc.com instead of this, and the name server name, name server. So we'll put here www.abc.com and the name server. The name server, it should be here. One of the name servers. And you can see that it is able to resolve your domain name. So when anyone resolves this domain name, this is internal now because it's not a public domain. They will get an IP address, whatever you have defined in your DNS records, right? So that's a simple example of how you manage your DNS, public DNS. So that's what we have done now. We have verified that. our DNS is working fine. So it is not a real public domain. This is how it will work for the real public DNS server as well. Now we are configuring private DNS zone. A private DNS zone provides name resolution services within virtual networks. A private DNS zone is only accessible from the virtual networks that is linked to and cannot be accessed from the internet. Okay, so the name itself tells you that it is a private DNS. It's meant for using internally on your virtual network, not for the public access. Let's look for the private DNS zones. Okay, we are here. Let's close this one. And here we have an option. Create private DNS zone. Select the subscription, the source group again, and the name of the domain. Let's say I want to make it abc.local. So since it is not a public domain, I can use any domain name here, what I want internally to be used. So I am saying abc.com .local actually. So if it is public domain, it has to be .com or .net or the publicly available root DNS servers or domain names. You can't use .local in the real world. So it says create. Now go to the resources. Is a private DNS something which you really need in the virtual network on Azure? You don't, right? You don't really need. It's not a mandatory requirement. It is an optional thing. It is for you to make your work easier, to have the name resolution activated on the servers. I'll pause here for a minute. There's a call to prayer happening. Okay, guys, I'm back with you. Let's complete this lab in next 10 minutes. Then we'll take a break for half an hour. Okay, so I've created a virtual private DNS zone. I'm going to the private DNS. You can see here, it's a private DNS zone, and my zone name is abc.local. So now we are going to the resources. We are there in the resource. Okay. Notice on the overview blade, there are no name servers. So in this, you can see that this is difference. Since it is a private DNS zone, it doesn't require any name servers, which are public name servers basically. So this will be only used for internal name resolution, not the public name resolution. Okay. Expand the DNS management blade and then select virtual networks. So DNS management blades, we expand that, and then we go to virtual networks, virtual network links. You can see your private DNS zone, you can link to virtual networks. So here what we are doing is link name, manufacturing link, click add. That's the name of the link, manufacturing VNet. And the name of the, so this is the name of our virtual network, right? We have that, yes, manufacturing VNet. That's our virtual network name. And then click create. So here you can see there's an option here, enable auto registration. So what happens when if you do this? I've explained you on the slide. When you create any virtual machine or when you rename any virtual machine, their names, the host names will be automatically updated in the DNS record. So the host records will be automatically updated in the DNS zone. So that's what the DNS is responsible for, right? Mapping the domain names and the host names with the IP addresses. So here in this lab, in this exercise, we are not enabling that for now. We'll just auto registration is not enabled. So we're just going to go ahead and create this one. Okay. And after that, we are creating a record manually. Okay. So the same way, what we have done on the public DNS zone, we created a public the host record manually. Here also we're creating it manually, but the good practice is you enable the auto registration so that you don't have to create this records for each and every server or the virtual machine which you build and deploy in your virtual network. So create, once it is created, okay, the link is created. That means this DNS is linked to this virtual network. Now in that virtual network, whatever VMs you have, if you have enabled the auto registration, their host names and IP addresses will be automatically registered here. But now we are manually creating it. So we are going to the DNS management again, record sets, going to the record sets, and you would now add a record for each virtual machine that needs name resolution. So we are going to create a name record for this name. This is the server name, and this is the type of the record, a record, and TTL value is 1. That's the refresh time. I'll explain you in the whiteboard where TTL value really matters. And this is the IP address. So you have the simple A record created for your virtual machine name. Sensor VM, the type of the record is A. This is the TTL value, and this is the actual IP address of the server. In real world scenarios, you would enter the IP address for a specific manufacturing virtual machine. Yeah, that's fine. And that's the end of our lab 4 basically. So what have we done now? I'll explain you quickly on the board and then we'll take a break. So now we have virtual network. Now, one single private DNS zone you can use for multiple VNets as well. So this is our VNet, and let's say we have multiple subnets in this. This is our production subnet, prod, and this is our development subnet. Okay, and we have virtual machines in this. I have VM1 as a name of the server, VM2, and they are having the IP addresses 1.1.1.1, 1.1.1.2. Just for your understanding, and these are two VMs here, VM1, VM2. But you cannot have the same virtual machine name. You should always use different names, unique names for the servers. So I'll say D-V1 development servers, D-V2. IP address and the host name should be unique in your environment. So here, let's say this is a separate subnet, right? Different subnet. So I have a subnet IP, for example, 1.1.2.1, 1.1.2.2. So I have four virtual machines now. So I'm activating my private DNS zone. This is my private DNS. I'm creating a zone name called abc.local. Okay, this is what I have done first. This is the first thing I've done. Step one, to activate the name resolution. Then the step two, what I've done is basically link this DNS zone to VNet. So I link the VNet. Then the step three, I've created a record, host record manually. So this is what I've done. Or instead of this, what you could have done is while creating the private DNS zone, you can enable auto register, which you can do even after creating the private DNS zone. That's not an issue. So this DNS zone is now, this is linked to this virtual network. Okay. So what happens in this scenario? If it is auto register enabled, uh, what we have done, we created a record, right? Manually, we created a record. For example, this one. Let's say VM1. We said this is the IP address of the VM1. So when you have this auto register enabled, what will happen? Auto register, it will create all these records automatically. So VM1, VM2, D-VM1, D-VM2 with its IP addresses and the DNS record 1.1.1.1, 1.1.1.2, 1.1.2.1, 1.1.2.2. So your DNS records will be automatically created. What is the advantage of this now? From this virtual machine, you can access this virtual machine with the name. You can access it with the VName, the VM name, the host name. //VM1 and any file share if you have, you can access that. You can even ping and see if the name resolution is happening. Ping VM1. This is for testing the connectivity, right? So this is what is the private DNS is. I hope it is clear. We'll take a break here and we'll continue after half an hour. Hello everyone, welcome back to the second half of our session today. We'll try to complete the topic inter-site communication. We stopped at the DNS. We have seen public DNS and the private DNS. Now let's begin with our presentation. I'm going to share the screen from my other machine. Actually, other desktop. 1 second. I'm not able to see this. Okay. So this is where we stopped. Now we are discussing inter-site connectivity. What is inter-site connectivity and where we need it? In this presentation, if you see, there's a diagram, a simple picture which explains the different regions and different virtual networks in each region. So you see, there's a West Central US region in which we have one virtual network deployed, and there's an AD server there running, Active Directory server. We have another virtual network created for Azure UK South region, and we have a VNet created for multiple VNets actually. In Azure UK South, we have two VNets and East Asia. So now connectivity between the VNets, how we can do that, and where we need it actually. Now, if it is just talking about our on-prem scenario example, you might be having a head office headquarters in the UK, and you might be having branch offices in United States and the Asia. So for that kind of setup, we always use WAN connectivity, wide area network. Through our internet connectivity over the internet, we connect to our different site to the central site from the branch offices. Right? In Azure, you don't have to do that. You don't have to buy a separate internet connection and the link and configure the VPN and so on. Since these sites, these virtual networks are built on Azure platform. They are deployed in Azure regions, and within the region there are multiple availability zones, and availability zone is nothing but a data center. So all the data centers across Azure network are connected with a high speed connection. So let me just show you a web page here. Okay, so you can see this. These are different availability zones across the globe, which Microsoft has, and this is Microsoft Global WAN, Wide Area Network. So they have all of their data centers, which are called as availability zones, connected over a high-speed fiber connectivity across the globe. So every data center is connected with every other data center, right? So that's the Azure WAN. So that's their backbone connection. You can call it a backbone connection between their data centers. And I think, is it interactive? Does it show anything? No, it's not interactive. So these are highly, you can just remember that this is the high speed connectivity between the Azure data centers. So all the resources which you're deploying on Azure is going to one of the data center, right? Based on the region which you're selecting. So in our labs, most of the time we are choosing East US region. So it is going to deploy those resources in that particular data center in the East US region. Right in the background, it's connected. All those data centers connected with a high-speed connection. So now it will be easier for us if we have multiple branches, multiple sites, multiple Azure subscriptions with different VNets configured. And if you want those VNets to connect to each other, we have multiple options available. One of them is the virtual network peering. It is called virtual network peering, and we'll see now in the next slides what exactly the network peering is. I hope you guys can hear me properly and you're able to see the presentation.
Yes, yes, we can hear
Right.
you.
So what is VNet peering and uses? That's what we are trying to understand here. Azure VNet peering is a way to two connect two virtual networks, VNets, in Azure, so so that they behave like one network. So basically, we are connecting two different networks. If it is a physical network, in your on-prem scenario, let's say you have a network on first floor and you have a network on a second floor of your office. In order to connect those two networks, you would rely on the physical connectivity, right? You will lay down the cable and connect one network to the other network. So in Azure platform, you don't have to do anything as such. This is all done in the background. All the networks are connected with the high-speed connections. I have just shown you the example of that. All you have to do is the configuration on your virtual networks. You have to enable the VNet pairing, and with the help of VNet pairing, you will be able to connect to you'll be able to connect different virtual networks together. So peering allows two VNets to talk to each other privately using Azure's internal backbone. So this is what I was explaining. It's the internal backbone network of Microsoft Azure. It's not that you're connecting over the internet to the other data center of Azure in a different region. It's this connectivity is going on Microsoft backbone, not the public internet. That's what you need to, uh, you know, what do you say, distinguish between the connection over the internet to different offices, different branches, and connectivity between the VNet, different VNets in Azure virtual networking. Key points: VNets can communicate with each other as if they are part of the same network. Traffic stays private and secure inside Azure's backbone. So your network traffic, your data which you're transferring from one virtual network to other virtual network, it won't be visible on the internet because it's not going to cross our any internet backbone. It's going over the Microsoft's own private network connection. Works across same region, VNet peering, or different region. So in this, you have two options when you want to pair virtual network from one virtual network to another. If you have two virtual networks within the same region, it's called local pairing. And if you want to do connectivity across different regions, then it is called global VNet pairing. So what is the advantage of doing the VNet pairing? Low latency, that means you will have a very good data transfer rate and high bandwidth. So you can transfer large amount of data within minutes. Okay, what is VNet pairing and uses? We are continuing with that. When do you use it? When you want two VNets to communicate privately. For example, here in this diagram, you can see I have a virtual network, separate virtual network created for the production and development. We have seen an example of where you can have a single virtual network, and within the single virtual network, you can even have a separate subnet for production and development, or you can even have a separate VNet. Remember, I told you there is no cost for the virtual networks which you create or the subnets, number of subnets you create. So you can create n number of virtual networks and the subnets. So this again comes down to your design part. When you're designing your network, you have to decide how you want to deploy your environment and manage it. So it depends on the size of the company and the requirement, right? So here in this image, you see we have two virtual networks created, production and development. And by default, between these virtual networks, there is no communication. That means the virtual machine here, which is sitting in this dev VNet, cannot reach this virtual machine in the production VNet. Whereas if it is within the same virtual network, if I have a server here, this server can talk to this server in a different subnet and within the same VNet. But if it is across different virtual networks, you have to make use of VNet pairing. You have to do the VNet pairing to make it possible for this virtual machine to talk to this virtual machine in a production VNet, right? When multiple environments, development, UAT need controlled connectivity. So this again, as I told you, all of these decisions comes down to your design your company's organization's requirement. How big is the requirement? Is their organization? How many servers you're deploying? How many virtual machines you'll be running? What services you will run? So based on those factors, you will design your network. One virtual network or multiple virtual network with multiple subnets. It's all uh, based on the business requirement. So this is what I've told you, local peering versus global peering. So if it is VNet to VNet communication, this part is missing here. It is between the VNets. So if it is a local VNet pairing, within the same region, if you're doing the VNet pairing, it is called local pairing. And if you are doing between across different regions, if you want to connect two virtual networks, that's called global VNet pairing. Okay, local versus global pairing. Here's some more detail on that. Pairing type, local pairing. There's a cost implication. Now, VNet to VNet pairing. Again, it's not free of cost. When you transfer the data, again, coming back to the same explanation, creating a virtual network itself, creating the subnets within it, and creating multiple virtual network and multiple subnets, and even doing the pairing between those virtual networks will not cost you anything unless you start transferring data, start sharing the data between the virtual networks. So that data transfer is actually something which the Microsoft will bill you on. So cost applies, yes, if not just for local pairing when you start transferring data and within the same region, because it's a local pairing, the cost of data transfer will be very less, very minimal. Like if it is a global pairing, and there is a different cost for transferring data. So if you are transferring 10 GB data, Microsoft has a set price for data transfer rate. For 1 GB, they'll cost you so much, and so on. So you can multiply that. That's available on the Microsoft website on Azure platform. You can use the Azure calculator as well, which we have seen before. Key points to remember: no cost for creating or maintaining the peering. You only pay for data transfer. Local peering is cheaper. Global peering is more expensive. The more traffic between winners, the higher the cost. Traffic stays on Azure backbone, not the public internet. So these are the key points which you have to remember, because these are again, all these points are related to your examination. So you might get questions regarding local pairing, global pairing, and the limitations of that each of this. Then we come to something called gateway transit and connectivity needs. Now, what does this mean? Gateway transit allows one VNet to use VPN or express route gateway of another VNet for hybrid connectivity on premises to Azure. I'll explain you this bit on a whiteboard. Instead of deploying multiple gateways in every VNet, you share a single gateway. Default VNet pairing provides full connectivity, and there is a note here, which again highlighting in the importance of choosing the IP address ranges for your virtual networks. So IP address spaces of connected networks cannot overlap. So if you are having two virtual networks with the same IP range, the connectivity will not work. It will fail. Okay, so here is an example of the gateway transit and connectivity need. This gives you a simple diagram wherein it explains you what it is. Let me go back to the whiteboard. I'll make it much more clear. Okay, I hope you can see the screen. So first of all, let's say we're talking about the VNets, the VNet peering. So I'm in UAE North region. So you know how you choose the region, right? While you are creating the resources. So here in North region, I have created two virtual networks, for example, as we have seen in the slides. I'm creating virtual networks for traffic segregation. This is for production, and this is for development. So all my resources which I deploy will be either production resources or the development resources. So if I have a server here or two servers, let's say this is my production server one, prod one, and prod two, and I have my servers in the development, dev one and dev two, right? So again, these servers will be part of our subnet. So you cannot straight away deploy the virtual machines in virtual network without having a subnet. So you'll have subnet defined, a VNet and the subnet defined. And you know that if I have multiple subnets, for example, this is subnet A and this is subnet B, and I have the servers here as well. So within the subnets, this communication is automatically allowed two-way. You can access any of the servers within your virtual network. But this connectivity, if this server, production server, for example, if the production server requires required to access this dev server, this won't be possible unless you do the VNet peering. So this connectivity will not work without VNet peering. So you will not have connectivity, and there's no way you can reach the other virtual machine in the other VNet. So what we do is we do a pairing here. This is called local pairing, local VNet pairing within the same region. This is important to understand. Within the same region, when you're doing it, it's called local VNet pairing. Now let's say I have another region, similar setup. I have US region, US East, where I have again a VNet. One second. Okay. So we have a VNet here, virtual network, again in this office in this location. So this is again related to production, for example. This is my headquarters, and this is my branch office. Let's say. So here I have some servers, some resources. So this is B1 server, B2 server, and these servers needs to access some resources from this VNet. Okay, how can you do that? By default, this communication is again not possible. You can't do this. There's no way you can have a connection, and it's not something which you own, that you lay down the cable from one region to other region. It's out of your control. So what you have to do in this scenario, you have an option of peering again, and this is called global peering. So this is local within the region, and this is global peering. The configuration process is still the same. The only difference is when you are creating the peering for the VNets within same region, it is called local peering. And when you create the peering between different regions, it's called global peering. I hope this is clear. Okay, now going back to the next one, which was transit gateway.
I have a question.
Yes, go ahead.
Can this
Hmm.
like can we communicate with other CSP like cloud service provider? Can Azure?
Not with this concept. Yes, we can have a connection between different CSPs, but not with the peering option which I'm explaining. This is purely within the cloud service provider, same cloud service provider.
Okay.
So we have different options available. If you want to connect different virtual networks across different cloud platforms. I'll explain you that as well, what option we have there. Okay, let's
Okay.
understand the Azure part, particularly here. Different VNets, different regions, local peering, global peering. Now, let's say we have an example. Okay, let's take the same example. So here we have a headquarters, we have a production VNet there, and we have a branch office. So where do we need the gateway transit? So for example, in this scenario, I have on-prem setup as well. This is my hybrid environment. So let's say I have on-prem data center, wherein I have my production servers again. Some of my application servers are running here. So app one, app two. Okay. Now, when you say hybrid setup, your hybrid environment, when will it become hybrid? When you have connectivity to the cloud, right? So I have my connectivity, I can establish my connectivity between this on-prem network with the Azure cloud region. So how is this done again? Now this is completely uh, out of Microsoft control, right? This on-prem setup is your own setup on-prem and in your office, in your data center facility, and you want to connect to the Azure network. So for hybrid connectivity, what you'll have to do is you have two options here. You can approach your ISP, which is the internet service provider, and they will provide you the link for connecting to the Azure. There are two options in this. Either you can do a VPN connection or you can do express route. Okay, these are two options you have for connecting your on-prem setup to the Azure cloud. So when you say express route, what this means is it's actually a private link. So your ISP will provide you a cable connectivity from your data center to the Microsoft data center in this region. So it's really a physical connectivity which they provide you. Okay. On top of that, you can do the configuration part. Logically, you have to configure it, but a physical dedicated private connection is provided from your on-premises data center. So of course, again, your ISP will assess whether this can be done or not. First of all, if your office, if your location data center is in a very remote area of the country, wherein there's no ISP connections available, you might not have option to go with this physical connectivity. Okay, so you definitely your ISP connection has to be available within the area where you have the data center, and they can provide you the physical connectivity from your data center. Of course, it will not be a point-to-point connection. That means from my data center, they are putting a cable and going back to Microsoft data center and connecting and plugging it in the Microsoft data center switch or the router. That's not the way it works. There will be multiple connectivity hubs in between. So that's ISP's job. They will take care of it. So, when a normal cable connection, which we get for our internet access at our home, it doesn't directly come from the ISP. It comes from multiple different distributors. So the main line will be connected, terminating somewhere else. From there, the local, your area service provider will pull a cable and bring it to your home. So similarly, when you go with express route, it's your as ISP's responsibility to make sure that you have a dedicated private connection from your on-prem to Microsoft data center within that region, right? If let's say you have your own your on-prem data center within the city limits, there is ISP connectivity available, but there's no Azure presence there. So in that case, you can't even have access route. So there are places where Microsoft doesn't have the data center in each and every city, right? So you can't really do the access route will not be feasible in that scenario. So it has to be within certain range of geographical area. That's the one way of doing it. So you can do that with the help of express route, with the help of physical connection. You can have express route. Otherwise, the very common connectivity type is VPN. So what do you need for doing the VPN? all you need on your site is the internet access. You need a very good internet connection, right? Again, that will be provided by your ISP. And Azure is anyway connected to the internet, right? Azure lives in the cloud. It's a cloud. Azure itself is a cloud. It's always connected to internet and always available to the users who are on internet. So through internet, you can establish something called VPN. So this is called a VPN connection. It will go over the internet. It will connect to your. It will make a connection between these two sites, and it will be an encrypted tunnel. It's called VPN tunnel. VPN tunnel. We'll be discussing VPN also in going forward. Just giving you the high level how the connectivity between the data center and the Azure data centers works. So VPN tunnel will be established. That's also called as site-to-site tunnel, S2S. There are different names of it. It's also called as IPsec tunnel. Okay, there are different names, but it's the same thing. VPN tunnel, IPsec tunnel, or site-to-site connection. It's all the same name of this type of connectivity. So with the help of VPN, you will have your connection established. Now you will be connecting to this region, right? Let's say you're having the VPN connection to your UAE North region. Now in this, what you have to do on Azure from the Azure side, you will have to configure this gateway. This is called gateway, VPN gateway, or let me tell you. This component, it doesn't really represent as round in reality. So this is a virtual component we have to configure. It's called VPN gateway, or it is also called as virtual what is it called? Virtual network appliance, VNA. Okay, what virtual network appliance. So there are different names of it again. So you have to deploy something called VPN gateway or the VNA virtual network appliance on your Azure platform. You will see how it is done actually. When you see it, you will definitely understand what I'm trying to explain. So what happens with this? This becomes a gateway, the gateway transit. So this network. So you actually associate this VPN gateway with the particular virtual network. For example, so I will just remove this part. So you will create and assign that gateway in the configuration to a particular virtual network. And in this scenario, now what will happen? From the branch office, if the user wants to access anything from the North UAE North region from the production environment, he can access the user or the machine can access this server, production 1 server or production 2 server. Now, can they access the application servers here in the on-prem data center? You have a connectivity, right? You have a global pairing between the VNets across 2 different regions. And here you have a connectivity, IPsec connectivity, or the site-to-site connection between the UAE North region virtual network and on-prem data center. So in this scenario, you can configure this VPN gateway as a transit gateway. It is called a transit gateway. This becomes a transit gateway. So you can use this using this. The users or the computers which are there in the branch office, they can access these resources in this VNet, as well as they can access this resource because there is a local pairing available. They can even access the resource on the on-prem network, right? So the traffic is transiting for the US server in the US. If there is a connection request from here to access your application server on-prem, so this is really what is happening. It's a transit. You can call it a transit connection. I'm sure you people who travel if you stop over on one of the on your journey, if you stop over on one location and then carry on from there, that's called your transit gateway, right? So you stop, suppose you're flying from Dubai to United States, but you're having a stopover in the UK. So that becomes your transit gateway. So you're stopping over there, and from there you're carrying on over to United States. So similar, that's an analogy I'm using here to explain you what the transit gateway means here and how transit gateway functions. I hope this is clear. This is all you can configure on Azure. Any doubts here? So in with this, we have a concept of uh, hub and spoke topology. It's called hub and spoke topology in networking terminology. Okay, so you'll have multiple virtual networks, multiple branches. For example, let's say this is my branch one, this is my branch two, this is my headquarters. Okay, so from here I'm establishing a connection to this. So all my resources are here. That means my core applications and data and all the services which I need for IT, they're all running here. So you'll have this connectivity. In this scenario, your headquarters becomes a hub site. Uh, so so we have a hub here, and this is called spoke in this topology. This is a hub and spoke topology in networking terminology. So this system from here, they can access both this branch office can access the resources from the hub side. So this you can implement again. So again, this will be the topology which you can use for extending your on-prem scenario on-prem connectivity. So if you have your on-prem network with the help of VPN, you can connect or the express route. So this becomes your transit point for your branch offices and from the on-prem for your on-prem systems as well, right? So that's what gateway transit and the gateway transit and the VPN gateways are about. I'm just going to share the screen again. Let's continue with the. Okay. The gateway transit use a gateway in a hub VNet. So hub VNet, you have seen which one will be called as hub VNet for on-premises access by spoke VNets. So your branch office is called as a spoke VNet. So that will access the on-prem setup through your main headquarter VNet, HQ VNet. Connectivity requirements for gateway transit. VNet peering must be enabled. That's required for connectivity between these VNets. VNets must not overlap in IP ranges. We know that it's a reminder again and again that you should not have overlapping IP addresses in the virtual networks. Only hub VNet has a gateway. So in this scenario, we have seen that only the hub VNet will have a gateway to access the on-prem resources. So all your connectivity from different VNets will come here to the hub VNet, and from here it will go to the on-prem data center or the express route or the VPN gateway. Traffic flow depends on network security policies, and you can differently define the network security policy to control the traffic flow. Why do we use gateway transit? Multiple VNets needs on-prem access. Uh, yeah, that's one of the reason. You want a hub and spoke topology to avoid high cost of multiple gateways. So this VPN gateway, which I have explained you on the whiteboard. So this VPN gateway which you're deploying here on this HQ, it also has a cost implication. There's a cost implication. So if you have multiple virtual networks, this branch office, this branch office, you can even have a VPN gateway here and have a side-to-side connectivity with your on-prem setup. But this will increase your cost. So instead of one, you're deploying three VPN gateways for each virtual network. So that's not ideal scenario. So in order to cut down that cost, you use the gateway transit option. You deploy the VPN only on your hub site, not on the spoke sites. Got it? All right, so let's get back to our presentation. Okay, what is service chaining in Azure? Service chaining means routing traffic through a specific security or network securities or network services before it reaches its destination. In Azure, this is done using NVA, Network Virtual Appliance. I was explaining you. We have something called Azure Firewall, and we have route tables, UDR. It is called user-defined routes, and we have hub and spoke architecture. So you can the concept of service chaining, I'll explain you in a bit. You basically force the traffic to pass through a security service, then route it to its destination. So let's have a whiteboard again on this one to explain before after completing our slides. We have many slides, I guess. There are 10 more slides in this itself. So I'll explain you what service chaining means. Review system routes. You have system routes are default routing rules automatically created and managed by Azure inside every VNet and subnet. You cannot delete the system routes like you can't delete the network security groups rules, default rules in the network security group. Similarly, you have some routes which are created automatically when you create the virtual network. So Azure uses them to make sure basic connectivity works. These routes decides how traffic flows by default if you don't override them with user-defined routes or BGP routes. So this is the routing table which is by default activated on the virtual network. So route type local VNet, VNet address space. Next hop is VNet, subnet to subnet routing. As I have explained you, within the virtual network, between the subnets, there is no issue. Yeah, you can access the virtual machine from one subnet to the other server, from the other subnet. Whereas if you are having two separate VNets, you cannot access the resources from other VNet subnets. On-premises, on-premises prefixes, VPN or ER gateway, edge router gateway, hybrid connectivity. So we'll see this. I'll explain you this on the whiteboard to make more sense. And there's a default route towards internet, outbound to internet. Review system routes. This is purely a routing concept and route engineering. I'll give you a very high level explanation, and that should be enough for you to understand how the traffic routes over the Azure network, Azure VNet basically. So you have VNet, we have multiple subnets here, local VNet route. So we have, if you do the VNet pairing, there will be route enabled for that. And there is a default route which goes to the internet. You know, by default, from all the virtual machines which you build within your virtual network, you are automatically given access to the internet. And that is done with the help of default route. So I'll explain you that on the whiteboard. That will be much more easier to understand. Then you have user-defined routes. You can, you as an administrator, you can define your own routing this is called route engineering. So this is the network terminology again. You can create the routes. I'll explain you where routing will help. Based on that, you can relate that information here. Custom routing rules that you can create to override Azure default system routes. Azure system routes default behavior. That's the default behavior, and then you can define your own UDR, user-defined route, your routing decision. Okay, you use UDRs to force traffic to a specific path. We'll see that. I'll probably go back to the whiteboard, but let's finish the slides. How many slides we have? Now we have service endpoint, we have private link, service endpoint versus private link. Okay, that's the last concept we have. So let's go back to the routing now, because that's what we need to understand. Service chaining and routing. We have seen what is the default, the gateway transit, how and where it is required. We see the service chaining. What is service chaining? Service chaining is mainly about you basically force the traffic to pass through a security service or the gate or the device. So why we need that service chaining? I'll tell you here. I'm sharing the screen again from whiteboard. Okay, let's say I have try to make it simple. I have a VNet. I have some subnets here. Production subnet and dev subnet. And there are VMs. Now in this scenario, you know that the communication between the subnets is automatically allowed, and every VNet has access to the internet. All the subnets within the VNet, they will have access to the internet without any extra configuration. So internet is available for access. And this network, now as per the best practices, I want to control this traffic to the internet. I want to have access to the internet. I want to provide access to these servers, but limited access to the internet. So you want to apply the rules and the policies for the internet access. Let's say I implement a firewall. Okay, a firewall. The next generation firewalls can do many things. It can do first of all the access control. We can define the rules, same as what NSG in NSG you do. In NSG we have created an access rule, right, to block the internet access, complete internet access. But you don't want to do that. You want to allow the internet access, but limited access. So let's say I want these servers, all of my servers, all servers to access the Microsoft site for downloading the updates, Microsoft.com. Okay. So with the help of firewall or any network security device, you can implement such rules, which won't be easily available in the network security group, NSG rules. And you can also inspect the traffic. Okay, you can have the inspection enabled. You can even have time-based rules, and you can have URL filtering. And so on. There are many features I'll explain you about the firewalls. So let's say I want to implement this firewall. So you know, we have seen there's something called Azure Marketplace. What is Azure Marketplace? Can anyone tell me? I want to hear from you guys. One of you. You don't remember? That's not an issue. It's similar to the App Store. right? Apple has an App Store and Google has something called Play Store, where you can buy the apps, right? You have free available apps, you have paid available apps. You can buy the apps from those app stores. For Apple, there is App Store. For Android phones, Android devices, it's the Play Store. Similarly, Azure has its own application store, wherein there are multiple applications which are built by different companies and which you can deploy in your Azure environment. So one of them we can look for it. We can, let's say I want to deploy a firewall from a company called Palo Alto. It's a security company and they have their own firewall product. So I can buy this from marketplace and implement in my network. So let's say I purchase the firewall. It's a virtual firewall again. It's not something physically which you go and put on Azure. So we're dealing with the virtual setup, completely virtual, right? But you can achieve everything what all the security levels what you can do on-prem. So if you need a firewall, custom firewall from a different vendor, you can do that. So within virtual network, you can create one more zone, one more. What do you say? You can extend your virtual network and create one more subnet, a firewall subnet. So let's say I have a subnet for firewall particularly. So here I will deploy a firewall, right? Now I deployed a firewall. It's up and running. This is a separate subnet I have created. Okay. Now what will happen? Even though I have a firewall deployed, my traffic by default will go to the internet directly. It will not come to the firewall and go to the internet. So I don't want that. So I want to stop this behavior. So by default, there's a default route which I've told you, which I've shown you. Default route means it basically says uh, 0.0.0 as an IP address. All the traffic which is destined for any IP address go to the internet. Internet connection is allowed. So if you are trying to access google.com, microsoft.com, all the sites are having the IP address in the background, right? So those IPs, when Azure Network VNet sees that, okay, these IPs do not belong to our virtual network or any subnet, it will directly send it to the send it over the internet connection. So through the gateway and the internet. So I need to stop, if I need to stop this behavior, because I have my own firewall now. I want to have a controlled access, provide controlled access to these users. So there's something called UDR. So you can do a user-defined route saying that, okay, this subnet, let's say this is my subnet 10.1.0.0/24, and this is my 10.2.0.0/24. These two subnets. So I can define the routes saying that, let's say this is my third subnet, 10.2. Sorry, yeah, 10.3.0.0/24. And this is my firewall, which has the IP address 10.3.1.10, just as an example. So I want to force the traffic from all the subnets to go to this firewall, and from there, from the firewall, it should go to the internet. That's what that's what is my requirement. How I can do that? I can do that with the help of VDR. By default, there's a default route which will automatically send the traffic from these subnets to internet, but not to the firewall which you have deployed. So to override that, you can't delete this rule. As you know, this is a system-defined route. You can't delete it, but you can override by writing the UDR route rules, UDR, saying that any traffic from 10.1.0.0/24, this is the source, and the destination is 0.0.0.0. That means internet forward this traffic to this IP. This will be the next hop. It is called next hop. in networking terminology. So this is my user-defined route for this particular subnet. So now when I try to browse internet, my internet traffic will not go to the default route. It will hit this user-defined route, and in the route you have implemented that anything coming from this subnet going towards internet, it should forward it to the firewall. So the firewall will receive the internet, this traffic, this request, and based on the rules and the policies which you have defined, it will allow the access to the internet. Okay, so you can define this is called enforcing the traffic flow. This is traffic engineering, basically in the networking terminology. So you implemented a firewall. Now you are forcing all your internet traffic to go through that firewall in order to have a control access on your internet for the servers. I hope that is clear. Any questions around that? So this covers 2-3 concepts here. Service chaining. Uh, Service chaining is also done with the help of UDR. You're enforcing a traffic for a specific subnet or a specific virtual network to go through a specific security service. So this is a security device. Firewall is nothing but my security device, network security device. So I'm enforcing the traffic to go through the firewall, which is not a default behavior in the virtual network. Service chaining, user-defined routes. We have seen system-defined routes, which are default. There's a default route which sends all the traffic from your servers directly to the internet by default. Right? So let's go back to the presentation. Okay, doing the same thing again. All right, so that is service sharing, basically. And then we have seen system routes. One of the example default route we have seen how default route is functions in the virtual network, and user defined route wherein you can enforce the traffic. As you have seen here, this is an example which I was showing you in the table. Second, we're defining a default route. Next hop is the virtual appliance, which is our firewall basically. So force all outbound traffic through the firewall. So that's what you can do with the help of user defined routes. Okay. Service endpoints and service links, private links. We have 2 things left. Let's quickly cover those. So what is a service endpoint? A service endpoint extends your VNet private IP space to an Azure service. Just by reading this sentence, we won't understand what exactly it means. This means your VM or subnet can access Azure services privately, even though the service itself has a public endpoint. I'll explain this again on the whiteboard. Here, there's an example given here in the picture. What does it say? Here we have a virtual network. This is our virtual network. This is our subnet. And in this subnet, we have a virtual machine. And this virtual machine needs access to, it's basically accessing a storage account. Okay. So this is a storage, Azure storage, which is available and accessible over the internet. Now, what we are doing here is VM private IP. So we are enabling a service endpoint. With this, we are avoiding this connection going over the internet, because this is since this is between Azure services. Azure storage account is also Azure service, and Azure virtual network is also Azure service. So you know that the storage account, we have created a storage account in previous exercise. You can create a storage account and you can make it available over the internet so that you can upload and download the files to your storage account, just like your OneDrive. Correct? We have seen that. So that storage account is publicly available and accessible. Now, for security reasons, if it is a storage account which is used for your corporate for your organization, you don't want that storage account to be accessible over the internet. You want that to be available and accessible within the virtual Microsoft network. So this all happens in the within Microsoft Azure network and through the Microsoft private connection, the backbone. So you can see this is what it's trying to explain here. This connection from the virtual machine to the storage is not going over the internet. It's going over the Microsoft backbone. So we can implement this. It's not by default activated. And there is something called private link. So there are two different things. One is service endpoint and one is the private link. Okay, now there's a quick comparison. Now, what is the private link? First of all, allows you to access Azure platform as a service privately using a private IP inside your VNet. So this is a connectivity between your infrastructure as a service to platform as a service domain of Microsoft. We'll see the scenarios. I'll explain you differently because this will not make sense if I just go through these points what are written there, but you can relate to it when I explain it on the whiteboard. So what is the feature here? IP type, service endpoint, public service IP, private IP inside the VNet. Let's not just read through it. We'll try to understand it on the whiteboard. So what else we have? There's another example here. Private link allows you to access Azure PaaS services privately using private IP. This is what it shows here. Service endpoint, virtual network, VNet service endpoint, and it shows internet over the internet. Private link, Azure service. Okay, let's continue and finish the slides. Then I'll explain you what is the service endpoint and the private link. If you see, the private link earlier used to be called as private endpoint. So there was a service endpoint and the private endpoint. Now they have renamed the private endpoint to private link. Uses service public endpoint, but traffic flows privately. Services get a private IP address inside your VNet. So we'll not read through this. I'll explain you. So that's end of our today's session from the presentation point of view. Now I'll try to explain you, or let's do one thing. These two things will require some configuration and explanation. The service endpoint and the private endpoint. These are linked to some other exercises going in the next sessions. What we can do is let's see this. What we have here. Implement inter-site connectivity. So this is another lab we have, and in this lab, what we are doing, you can see that we are doing connectivity between different same region. It's not a different region, ECUS and ECUS, but two different virtual networks, core services VNet and the manufacturing VNet. So I think we are going to do a VNet peering. Create a virtual machine in the virtual network. Okay, here we have exercises creating the virtual machines also. Then we'll be creating virtual machine different virtual network. Okay. Use network watcher to test the connection between virtual machines. Okay. Then we have configure virtual network peering between different virtual networks. Use Azure PowerShell to test the connection. That's fine. Create a custom route. So all of those things which we have discussed are covered in this lab. So look, you can see here it is stopping at the route, the custom route, which we have discussed. User defined route. So we don't have the private link and the service endpoint explained here. So we'll keep it for the next session. And this is the next lab we'll be doing. But I guess it will take a long time because I just don't want to, follow this step by step and finish this lab without you understanding it. So it's a long lab. We'll keep it for the next session. So you have 10 minutes left. If you want to have any Q&A, you can do that, or we can wrap up this session for today. There are too many things we have discussed purely about networking. So if you're not having any background from the networking, it will be really difficult for you to understand. I understand that. But I would again suggest you something. Whatever topics you're covering on each weekend, if those topics are new to you, completely new, go and do some research by yourself, watch some YouTube videos, just specifically about that particular topic. So let's say I've explained you VNet pairing, right? So go and watch video only related to that topic specifically. So don't get yourself confused and overloaded. The topics which are very new, you should do some research on it because this is the admin series, and in this admin series, Microsoft itself says that there's a prerequisite that you should understand the fundamentals very well, IP addressing, OSI layers, and the basic networking concepts. And this is and also system admin administration. So those are the prerequisites for doing this course. So I'm trying to simplify it. I'm trying to explain it in a very simple way. But still, if you're totally new, it will be very difficult to understand. I even have gone through such situation on the topics which I don't, which I've never covered or never studied. So with that, uh, I will ask you one more time. If you have any questions, do let me know. If you have any issues with the labs, let me know. We can go through it together right away in this session. We have 10 minutes left, or we can pack up and meet next weekend for the next session. Okay. If I don't hear from anyone, I take that as okay from everyone and can conclude the session. Yes, Khaja.
Masood bhai, one thing, I can create a this Azure subscription with same credit card again because it's not allowing when I'm trying to create another account.
Why you creating another account?
I deleted the subscription.
Delete. Great. You deleted the subscription itself.
Yeah, while doing the live, yes, I don't know how come it's deleted.
Okay, so I'm not sure. It's not allowing you to create another subscription, you're saying. So
Yes.
probably what we can do is we can restore the subscription which you deleted.
Okay.
We can, I'll check, I'll look into that. I'll suggest you how we can do that,
Okay. Done. Done. Done.
right?
Done.
So
Thank you.
but you did this recently, the subscription which you created?
Yes. 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 3 days before only 3 days while I'm
Okay,
doing the live. Yes.
all right, no issues. So I'll check that. I'll check and suggest you how we can get around that,
Okay. Okay. Done.
right?
Thank you. Thank you very
Okay,
much.
then I don't hear from anyone. That means no one has a doubt or no one has understood anything at all. So either one of these two. So please do some research on your own. Spend some time because the topics from here it's all going to be advanced topics. But I'm trying to simplify in a very simple way, simple language, so that you understand and relate it to the real-time scenarios. Have a good day and see you next week, inshallah.
Okay.
Take care.
Thank you. Thank you. Assalamu alaikum.
Waalaikum salam.
Thank you. Thank you.